This is an introduction to the iDelve technology, which serves to accelerate the map viewing experience for enterprise. Let's start with the current web-based map viewing technique for comparison. Images and vectors are combined to create maps at all zoom levels, called a tile pyramid. It's a time-consuming process that can then save time when a map is requested. The problem occurs when the data changes to the editing or real-time process. This requires the tiles affected by the change to be discarded and refreshed all the way through the pyramid. Because of the time involved, this is impractical for real-time data. Let's consider the iDelve methodology. We will need to show both vector and raster data. iDelve is unique in treating and delivering them natively. Raster data is used to produce a tile pyramid on an as-needed basis, and this allows for commonly accessed data to be cached at all resolutions, and for less frequently accessed areas to be delivered and officially cached at less resolution. Meanwhile, vector data is retrieved, distilled and deconstructed in a special form. It's ready for delivery using its dynamic vector resolution capability, or what you need is what you get. Finally, we deliver the map, tile and vector to create the final composite display. Now, when vector features are changed, we simply delete the deconstructed object, regenerate a new deconstructed vector form, and then refresh it on the display. In this way, a dynamic raster and vectored composite image is efficiently transmitted. In order to build the best vector map server, we need first to be able to retrieve the data. By building in heterogeneous database and server connection capabilities to accommodate the industry norms, and then we employ a deconstruction technique to store vector feature essences. This has its analogy in a tile pyramid, or more accurately, perhaps a distillation or fractioning process. We store the final essences in a cache, and then we build the delivery process. Now, the feature is called in for synchronization. It's drawn into the engine, deconstructed, and then stored. In the retrieval process, a map client requests a feature. Its essence is delivered to produce a representation at that scale. The user may then zoom in, and the feature details then need to be updated. Increments are sent to update the existing vector feature. But how does this work at the client? The iDelve map viewing client is integral to the system. It needs to perform the display and update of features based upon the data it receives from the server. It does this with client-side processing using either Java or JavaScript and HTML5, and it also uses caching. This accelerates and provides some basic offline capabilities. To provide full advantage of the iDelve Fusion product, it incorporates an interface for layers, markup, features and functions, with a rich API to the server. Finally, it manages the extents and resolution of the server to ensure that what you need is what you get, or WYSIWYG. In trying to illustrate the iDelve technology, you can see here a map painstakingly captured in that brief moment before the rendering finished. You can see the low resolution vectors from the previous zoom level. Moving forwards, these are rendered in a time frame that's almost imperceptible to the end user. And the result is in a progressively refined, high resolution outline. Just for comparison, another map is provided that uses the typical tiling method. It's often required to incorporate remote data in a map, and usually this is done through WFS. When fetching a map, the local data is quick, while the remote data trickles through. The size and bandwidth limits the ability to fuse this data. Only when we have all the data can we view the final map. iDelve Connect allows the efficient local fusion of data with scheduled and throttled pre-fetching of the remote WFS data. This incorporates data from other data custodians and spatial data infrastructure. The retrieval process can also trigger reprojection and translation events. The now local data allows vastly accelerated display of maps. One of the most challenging situations would be to represent local and remote land parcel data less than 24 hours old, and to do this in a rapid pan and zoom with full overlay and tabular data via the web. Other YouTube presentations exist to demonstrate the user capabilities, including a demonstration GIS toolset. Thanks for your time, and feel free to contact Amrastar for feedback and more information.